Okay, 2 more sections in this chapter. Woohoo! Absolute value. We've talked about absolute value in the past where you've had to find the absolute value of numbers. So right here, the absolute value of -4, I know you know is 4. And the absolute value of +4, I know you know is 4. Which brings us to when we have a problem like the absolute value of x is equal to 4. Well, we've just seen that x could be a negative or x could be a positive. We don't know which one it is. So since it could be both, we have to consider both possibilities. And that's just when this is x. When we start putting more than one thing in there, that's going to change this even more. So we need to come up with a way of making sure we always consider both possibilities. Because we don't know which one it is. So there are 2 cases that you always have to have. You'll always have the positive case whenever it comes to absolute values and a negative case whenever it comes to absolute values. And you're solving them. You always need to set up a positive case and a negative case. Always 2 every time. So for the positive case, the way you set it up is you take the absolute value bars off. So that would just be an x. And everything stays the same. So I would get x is equal to 4. Simple enough. For my negative case, I take the absolute value bars off the side that they're on, and then on the other side, I have to switch the sign of whatever number's over there. So in this case, it was a 4, so now it's a -4. That's how we got that x was equal to 4, -4. Always got to have 2 cases. Before you can start worrying about taking the absolute value bars off, you have to make sure you isolate your absolute value first. So that's why I wrote that down. So right here, my absolute value is already isolated. It's on one side by itself equal to some number. So we're all good with that. Now is when I need to take my absolute value bars off. So I have to have my 2 cases. So I'm going to put my positive case over here and my negative case over here. That doesn't mean that my answer here is going to be positive and my answer there is going to be negative. It has nothing to do with it. Does not mean that the stuff over here has to be positive inside or outside. Doesn't mean that the stuff over here has to be negative inside or outside. It has nothing to do with that. All it means is that on this side, everything stays the exact same as it was up there. I'm just taking the bars off. And the negative means that everything stays the exact same it was up there. I'm just changing this sign. So if this was a negative, I'd write a positive. But right now it's positive, so I'm going to write a negative. Now I have 2 separate problems that need to be solved. Over here, I subtract the 7 from both sides. In between is an OR problem. Absolute value signs are always an OR problem unless, that's not true. That's not what makes them an OR problem. Equal signs are always an OR problem unless told otherwise. So my answer, if I wanted to write the answer, this would be fine. I'd be okay with that for an answer. Or I'd be okay with that for an answer. Or x such that x is equal to 1 or -15. That for an answer. Not that you really wanted to see that one. Or I'd be okay with because that means the same thing as that, where the answer is 1 or 5. I anticipate you're going to leave it that way. I would leave it that way if I were you. I just want you to know, all these are possible. I'm not going to holler at any of them. If they say solution set, make sure it gets put in set notation. That's all I'm saying. Okay, let's look at another one. or 2 or 3. Absolute value of x plus 6 minus 7 is equal to negative 4. Remember I told you needed to isolate the absolute value first? Well, it's not alone. We've got this 7 here, so I'm going to go ahead and add 7 to both sides. That gives me the absolute value of x plus 6 equals 3. Now that I have it by itself, I can go ahead and split it up into a positive and negative case. So that means that x plus 6 is equal to 3, or x plus 6 is equal to negative 3. See, once popped them, moving on. Minus 6 from both sides. Minus 6 from both sides. So x equals negative 3 or x equals negative 9. Both of those answers will work. Two more. Absolute value of 2x minus 1 equals 3t. And the absolute value of 4 minus 2 and minus 1, absolute value equals 3. I'll give you a couple of seconds to work on those. Pause it. Take your own couple of seconds to work on them. Okay. For this one, the absolute value is already isolated. So I have 2x minus 1 equals 3t, or 2x minus 1 equals negative 3t. Subtract 3t from both sides. I guess this should probably be a t. It's been a long day. So that gives me negative t minus 1 equals 0. Add 1 to both sides. Negative t equals 1. Divide both sides by negative 1. T is equal to negative 1. Solving this one, or because of the equal sign. The other one isn't quite as simple because there's more stuff to do. But we do have the absolute value already isolated. So that means that it's 4 minus 2n minus 1 is equal to 3, or 4 minus 2n minus 1 is equal to negative 3. 4 minus 2n plus 2 is equal to 3. 4 and 2 is 6 minus 2n is equal to 3. Move my 6. Negative 2n equals negative 3. Divide by negative 2. n is equal to 3 over 2. Six minus 2n is equal to negative 3 minus 6. Negative 2n is equal to negative 9. N is equal to positive 9 over 2. And nobody died. That's always a positive thing. Nobody dies. Dying is sad. I hope nobody died. I say this when nobody had died. How about that? So, page 208. Classwork. Practice exercises. Numbers 4 through 8 even. And 18, 22, 28, and 38. Homework. Practice exercises. Numbers 1, 5, 9, 13, 17, 21, 25, 29, 33, 37. I know you think that's a lot. 10 problems in homework and a lot of problems in classwork. That is quite a bit, but I have to have you perfect at this before we go on to the next section, which is tomorrow. So I need you to get perfect at it today. So I need you to practice a lot so that you can get this done. I don't care if they tell you to check it. I'm happy with you checking it in the back of the book. Don't worry about whatever method it is they're talking about. Go ahead and solve it the way I've taught you to solve it. Everything will be fine that way. You don't have to graph any of these. You don't have to write solution sets. All you have to do is solve them. So make sure you get a positive case and a negative case for each one. You can run through them real quick. Okay. I will see you tomorrow, or you will see me tomorrow. I'll see you sometime. Bye.